Welcome to Barishal Cadet College and good morning to you all. Hope you all are fine at your home. Dear cadets, you have to follow the preventive tips for your safety. Firstly, wash hands with water and soap or sanitizer at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose or mouth with unwashed hands. Don't eat raw food, thoroughly cook meat and eggs. Avoid contact with animals and animal product. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I am Abu Said, lecturer, Department of Mathematics, Barishal Cadet College. In this class, I am going to discuss derivative of inverse function from chapter 9F of your book. Learning outcome. After the class, you will be able to explain inverse function, determine derivative of inverse functions. Derivative of inverse function. If y is a function of x, then dy by dx is the derivative of y with respect to x. If, again I repeat, if y is a function of x, then dy by dx is the derivative of y with respect to x. Again, if x is the inverse of function y, if x is the inverse of the function y, then dx by dy is the derivative of x with respect to y. If x is equal to f inverse y, then y is equal to f of x and dy by dx is equal to 1 by dx by dy, where none of the derivative is 0. In the same way, with derivative of the inverse circular function, we find the inverse of sine inverse function. Now solve. Let y is equal to sine inverse x, then x is equal to sine y. Let y is equal to sine inverse x, then we can write x is equal to sine y. Therefore, dx by dy is equal to, we know, dx by dy, that means sine, if we differentiate sine y, then we can write sine y dy by dx sine x is equal to cos x. That's why we can write dx by dy sine y is equal to cos y is equal to, we can write cos y is equal to root 1 minus sine square y, because we know sine square x plus cos square x is equal to 1. From this formula, we can write cos y is equal to root 1 minus sine square y. Now putting the value sine y is equal to x. Now here putting the value sine y is equal to x, then we can write root 1 minus x square. Then we can write dy by dx is equal to 1 by dx by dy. Here dx by dy means root 1 minus x square. Now putting the value here, then we can write 1 by root 1 minus sine is 1 minus x square. Thus d by dx sine inverse x. Here y means sine inverse x. So d by dx sine inverse x is equal to 1 by root 1 minus x square. When we solve problems, then we use this formula. Previously, we use d by dx sine x is equal to cos x. Now, when the given function inverse function, then we can write d by dx sine inverse x is equal to 1 by root 1 minus x square. In the same way, we can find d by dx cos inverse x is equal to minus 1 divided by root 1 minus x square. D by dx tan inverse x is equal to 1 by 1 plus x square. D by dx cot inverse x is equal to minus 1 by 1 plus x square. D by dx sec inverse x is equal to 1 by mod of x root x square minus 1 d by dx cosec inverse x is equal to minus 1 by x root x square minus 1. We apply this formula when we solve mathematical problems. Now let us try to solve some problems. Here given function root sine inverse x to the power 5. Here first function root. Then we differentiate inverse sine inverse x. X means x to the power 5. Then we apply x to the power n formula. That finally we apply here three formula. Firstly, then we solve. Now solution d by dx root sine inverse x to the power 5. Here we know root x is equal to 1 by 2 root x. Here x means sine inverse x to the power 5. That's why we can write d by dx root sine inverse x to the power 5 is equal to 1 by 2 root sine inverse x to the power 5. Now the remaining part d by dx sine inverse x to the power 5. We know d by dx sine inverse x is equal to 1 by root 1 minus x square. That's why you can write 1 by 2 root sine inverse x to the power 5 d by dx sine inverse x. That means 1 by root 1 minus x square. X square means x to the power 5. Here x means x to the power 5. X to the power 5 square. Then we differentiate x to the power 5. Here x to the power 5. That means d by dx x to the power 5. We know the formula x to the power d by dx x to the power n is equal to n x to the power n minus 1. Now applying this formula here, we can write 5 x to the power n minus 1. That means 5 minus 1. That means x to the power 4. 5 x to the power 4. Multiplying this, then we can write 5x to the power 4 by 2 root sine inverse x to the power 5 root 1 minus x to the power 10. This is our required answer. Now another question. Find the derivative with respect to x. Tan inverse root a minus b by a plus b tan x by 2. Here first given tan inverse x. X means total term root a minus b by a plus b tan x by 2. Then here this term are constant, and then we differentiate tan x by 2. Now solution. Here given that this function, that means d by dx tan inverse root a minus b by a plus b tan x by 2. Now we know tan inverse x is equal to 1 by 1 plus x square. Here x means this total term. That's why we can write 1 by 1 plus x square. That means square means a minus b by a plus b tan square x by 2. Now this part, this portion is complete. Now remaining part here a root a minus b by a plus b. This is constant term. That's why this term is common. And d by dx tan x by 2. Now 1 by, we know tan x is equal to sin x by cos x. That's why we can write 1 plus a minus b sin square x by 2 by a plus b cos square x by 2 root a minus b by a plus b, and d by dx tan x is equal to sec square x. That's why we can write sec square x by 2. Again, here the remaining part x by 2. That means d by dx x by 2 is equal to, we can write half. Because we know dx by dx is equal to 1. That's why you can write half. Now LCM a cos square x by 2 plus sin square x by 2 plus b into cos square x by 2 minus sin square x by 2 and a plus b cos square x by 2 and half root a minus b by a plus b cos square x by 2 1 by cos square x by 2. Now root a plus b and a plus b cancel, root a plus b cancel. The remaining part root a plus b into root a minus b. This part remaining of the remainder, and cos square x by 2 cos square x by 2 cancel. And now we know cos sin square x plus cos square x is equal to 1. That's why here remaining part A, and here another formula. We know cos square x minus sin square x is equal to cos 2x. Here x means x by 2. 2 cancel. That's why you can write b cos x. Again, I repeat, we know cos square x minus sin square x is equal to cos 2x. That's why we can write b cos 2x. The 2 into x means x by 2. Here 2 cancel. That's why directly we can write b cos x. Now a plus b into a minus b. That's why you can write a square root a square minus b square divided by 2 into a plus b cos x. This is our required answer. Now another question. Find the derivative with respect to x. X square sin inverse 1 minus x. Here applying the UV formula. Here u means x square and v means sin inverse 1 minus x, because here given two functions. Now solution. D by dx sin square sin in x square sin inverse 1 minus x. Now we know the formula u d by dx uv. That means u d by dx v plus v d by dx u. Applying this formula here, then we can write x square d by dx sin inverse 1 minus x plus sin inverse 1 minus x d by dx x square. Now we know sin inverse x is equal to 1 by root 1 minus x square. Here x square means 1 minus x. And if we again differentiate this term, then we can write 1. If we differentiate 1, then 0, and minus x means minus 1. And plus sin inverse 1 minus x, and here x square means x to the power n. That means 2x n minus 1. That means 2 minus 1. That's why we can write 2x. Now after calculation, we can write minus x square by root 1 minus 1 plus 2x minus x square plus 2x by sin inverse 1 minus x. Then finally we can write 2x sin inverse 1 minus x square by root 2x minus x square. This is our required answer. Now another question. Find the derivative with respect to x. Tan inverse x square by e to the power x plus tan inverse e to the power x by x square. Here we apply a new formula. Here tan inverse x plus tan inverse y. We know tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. Now solution. Here given that tan inverse x square by e to the power x plus tan inverse e to the power x by x square. We know tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Applying this formula here, then we can write tan inverse x means x square by e to the power x, and y means e to the power x by x square by 1 minus x square by e to the power x, e to the power x by x square. Now here e to the power x, e to the power x cancel, x square cancel. That's why you can write tan inverse x square by e to the power x plus e to the power x by x square 1 minus 1. We know cot inverse is the opposite of tan inverse. That's why you can write cot inverse is equal to 1 minus 1 by x square by e to the power x plus e to the power x by x square. Here 1 minus 1, that means 0 by something, that means 0. Cot inverse 0. We know cot 0, cot pi by 2 is equal to 0. That's why you can write cot inverse 0 is equal to pi by 2. Now d by dx tan inverse x square by e to the power x plus tan inverse e to the power x by x square is equal to d by dx pi by 2. Here pi by 2 constant term, that's why you can write 0. This is our required answer. Now another question. Find the derivative with respect to x. X square plus 1 tan inverse x minus x. Here given function this function, let y is equal to x square plus 1 tan inverse x minus x. Now dy by dx, x square plus 1, here UV formula, then this term. Then x square plus 1 is equal to x square plus 1 d by dx tan inverse x plus tan inverse x d by dx x square plus 1 minus d by dx x. Now we can write, we know tan inverse x is equal to 1 by 1 plus x square. That's why we can write x square plus 1 into 1 by 1 plus x square plus tan inverse x. If we differentiate this term, x square is equal to 2x minus 1. Now this term will cancel, then we can write 1 plus 2x tan inverse x minus 1. Here 1 cancel. That's why we can write 2x tan inverse x. This is our required answer. Now another question. Find the derivative with respect to x. Tan inverse a plus bx by a minus bx. Now solution, given that tan inverse a plus bx by a minus bx, here a common and also here a common, then we can write 1 plus b by a x divided by, if we a common, 1 minus b by a to the power x, here a cancel, then we can write tan inverse 1 plus b by x into 1 minus 1 into b by x, because we know tan inverse 1 plus x plus y divided 1 minus xy is equal to tan inverse x plus tan inverse y. Now applying this formula here, again I repeat, we know tan inverse x plus y by divided 1 minus xy is equal to, we can write tan inverse x plus tan inverse y. Applying this formula here, then we can write tan inverse x means 1 and y means b by x. Here x means 1 and y means b by a. That's why we can write tan inverse 1 minus tan inverse b by a into x. We know tan pi by 4 is equal to 1. That's why you can write pi by 4 minus tan inverse b by a into x. Now d by dx tan inverse a plus bx by a minus bx is equal to d by dx pi by 4 tan inverse b by a into x. Here b by a constant term. Here pi by 4 constant. That's why if we differentiate this term, then b is equal to 0, because we know d by dx into c is equal to 0. Here tan inverse x is equal to, we know 1 by 1 plus x square. Here x means this total term. That's why you can write 1 by 1 plus b by a x whole square into d by dx b by a into x. Here b by a constant term, and if we differentiate dx by dx, that means 1. That's why we can write a square into a square plus b square x square into b by a. Now after calculating, we can write ab by a square plus b square x square. This is our required answer. Now another question. Find the derivative with respect to x cos inverse 1 plus x by 2 to the power half. Then firstly, we simplify this function. That's why let y is equal to this function cos inverse 1 plus x by 2 to the power half, and let x is equal to cos theta. Then we can write theta is equal to cos inverse x. Now putting this value here, then we can write y is equal to cos inverse half into 1 plus cos theta. X means cos theta. We know 1 plus cos 2 theta is equal to 2 cos square theta. Here theta means 2 into theta by 2. That's why you can write cos inverse cos square theta by 2 to the power half. Now cos inverse cos theta by 2 square root square cancel. That's why you can write cos inverse cos theta by 2. Here cos inverse cancel. That's why theta by 2, the remaining part. And we know theta is equal to cos inverse x. Here putting this value, that means half cos inverse x. Now we differentiate this term, then we can write d by dx half cos inverse x. We know cos inverse x is equal to minus 1 by root 1 minus x square. Applying this formula here, then this is our required answer. Now this is your homework. Find the derivative with respect to x. Tan inverse 1 minus root x by 1 plus root x. Find the derivative with respect to x, e to the power x sin inverse x. Find the derivative with respect to x, sin inverse tan inverse x. That's all for today. If you have any query, you can ask that in the comment section. Lastly, I would like to remind you the most important thing. In this critical situation, you must stay home and keep yourself safe. Stay fine. Thank you.